Suppose in an Alta's mount, suppose Orion is rising from here. It's something like this. Slowly it will rise above. It is because the polar axis is there. It will rise above, it will be visible like this. And it will set like this. So if you see, here it was lying down and here it was vertical. That's how the sky moves. With the Alta's mount, what will happen? My frame camera is like this, or my view is like this, Orion is like this. After a while, when Orion is like this, my camera is still like that. So in my view, the whole view has rotated. So you get something called as field rotation in this equatorial mount. It is not good for astrophotography, for deep sky photography. You can shoot planets, you can shoot moon, and you can do very short exposures for deep sky photography. The kind of problem you get if you give a long exposure in a Alta's mount is something like this. So if this is a picture of Andromeda, and everything in the center, if you see, is perfectly tracking. The tracking is fine, but my field is rotating. That's why my view is like I'm getting this sort of phases. So this is the problem with the Alta's mount. Alta's mounts are good for viewing and shooting planets and moon. Benefit of Alta's mount is it's easier to use and it is lighter and easier to assemble. Next. Now, solution of this field rotation is GOTO mount. Oh, sorry, not a GOTO, sorry. Equatorial mount. You can convert a Alta's mount to equatorial mount by tilting it towards the polar axis. So normally Alta's mount is kept straight, and there's an accessory you can put it at an angle.
Azimuth axis become polar axis.
Yeah, so the axis pointing towards the head, like the azimuth axis, becomes the polar axis. Now this can track objects without field rotation. This type of design is called a fork mount because it has two forks coming to the side and the telescope is held in the middle. Next. Next. Another option is a German equatorial mount. So this is a German equatorial mount, and here we have a telescope here. And on the telescope, on the opposite side, we have this round things, which is just a weight. This is just a piece of iron or metal, which is just to balance it. The idea of this is the telescope is, whenever I leave it anywhere, it's balanced. This telescope is balanced by this weight. So it does not move whenever I leave it. Now, the telescope is also balanced in this axis. So by shifting the tube up and front and back, this is also balanced. So this design is called a German equatorial mount. Now how does it work is, like whenever I point at something like this, suppose at the horizon, it is going to slowly track like this, and slowly track like this, and you can track. So there are a lot of benefits that are more sturdy than compared to converting a fork mount, like for example, like Alta's mount at an angle. They are more sturdy, so they are like, you can put more weight on top of it. Next.
Now one thing happening, a very large telescope, they are going back to ultra-azimuth mount.
Yeah.
But they have very precise engineering and very good software to control that.
The camera rotates.
Yeah, camera rotation, the camera rotation.
So now, for example, all around you, for example, Earth, and around the Earth are stars everywhere, like down, up, below the pole, like for example, above the South Pole, above the North Pole, above everywhere around you have stars. So it appears like a round sphere around you. It's not a real sphere, but everything is at an infinite distance. Everything you cannot differentiate with your eyes what the distance is. So everything appears same and it's all around you, so it appears like a sphere. So just like the latitudes and longitudes on Earth, there is something called as the similar coordinate system is followed in the sky. That is RA and dec. So what happens, corresponding to the latitudes, we have declination. So this is the equator. So for example, the stars just in front of the equator, which is divided, for example, just like the equator of the Earth, which divides the Earth into northern hemisphere and southern hemisphere, the equator of the sky, the celestial equator we call it, can divide the sky into the northern sky and the southern sky. And starting from here, the declinations are there. So just like latitudes, these lines, lateral lines, and it's measured in degrees. Then comes RA, right ascension. Just like longitude, we have RA. So, for example, in this mount, where is RA? The movement of RA is this. So now, for example, this is the movement of RA. We are changing the RA, and this is the declination. Imagine that is the pole, and if I go towards the southern pole, so this is the celestial equator from the pole. For example, the pole is here, the telescope is pointing at the pole, this is the celestial equator. इसमें आवाज आ रही है उधर? Celestial equator. So, for example, this is 0 degree declination, and if we go slowly, the declination, the declination is increasing like this and toward the south pole also. RA is like longitude, for example, this is a pole, so longitudinal lines like this, and you are changing the RA like this. So this movement, when the counterweight moves, is RA, and this is declination. Thank you. Next. Now, the axis of the mount, suppose you are standing here, compared to the pole,